Thank you so much, Dental and Oral Health. So I am sharing my presentation within 2 minutes. So I am going to speak about the some revolutionary approach, which is a three-dimensional printing technology. So dentistry basically goes towards a technologically process which is considered to be the future that would change the manufacturing process. Three-dimensional printing is one of the latest addition to the dentistry, as we know that it basically prints an object where a three-dimensional object or any kind of a product which is made through a computer-aided design model. The evolution of the three-dimensional printing, imaging, and modeling in the industry is progressing towards one of the more efficient as well as the cost-effective workflow using the state-of-art and technology. This technology is one of an extremely versatile and the rapid process and a minimal wastage of the material. Okay. So, three-dimensional printing is basically the digital dentistry where there is an extensive penetrating opportunity in the diagnosis, treatment, as well as the education to the patient, along with the counseling of the patient. With the help of the three-dimensional printing technology, it makes the possibility of the complex geometrical forms to the simplest as well as the accurate digital data. However, in the conventional time or in the traditional time, the subtractive manufacturing process or the milling process that was used to form the replica of an object. But it has a certain pros and cons. The first most important pros and cons is it was a time-consuming process, and there is a more amount of wastage of the material. Even more than 90% of the material was wasted with the subtractive milling process. So that is why this is three-dimensional technology that will come into the evolution as a revolutionary approach in the dentistry. So, if we talk about the historical era of this three-dimensional printing, so Charles W. Hull, in the year 1984, he was an American engineer and was pioneered the solid imaging process, which is referred to as a stereolithography, and he was considered the father of the three-dimensional printer. So, various other researchers they did a lot of work on the three-dimensional printing process. There was a one more researcher, Scott and Lisa Crump, in 1989. He developed one of the modeling process, which is called the FDM modeling process, the fused deposition modeling process. And it was manufactured by a dental company that is a Stressless Limited. And even in the orthodontic department as a mini screw, this SLA technique was used in the year of 2011. So the three-dimensional printing process that will come into a clinical process or into the dental clinics in the by the era of 2011. Before that, it was just into the era of in vitro studies in the literature. So now we will talk about what is three-dimensional printing and how the three-dimensional printing works. Three-dimensional printing, as we know, it is an additive approach of a manufacturing of an object, which is the blueprint of an object. So here there are total in number three steps are there. One is the modeling, second one is the printing, third one is the finishing of the process. That is also the three principles of this three-dimensional printing process. So in the modeling, what they will do in the modeling, they will collect the data of an object and it will further transfer into the computer software, which is called the CAD software. So in the printing, what will happen? There is a G code file is there. So I'll show you the picture here. So this is the G code file. So this G code file is become activated and there is this installation of this G code file and there is a deposition or section of the replica of an object into the layer which is a start depositing of a replica of an object. And then this G code file instructions, they are further followed by the printer to lay down the successive layers of the material in order to build the three-dimensional replica process. No doubt it is a time-consuming process, but it will give you 100%, 99.9% to 100% accuracy to form the replica of an object, and the final object will be formed. So in the third step, when the finishing was done, it was only done when the model or the replica which was produced, if it will become an oversized, or there may be some kind of a surface roughness which may be present. So therefore, a layer by layer, an extra material that has to be removed for an accurate fitting. This is how the steps of a three-dimensional printing that will be followed through the modeling process, or through the printing process, or through any kind of a finishing. So this is, for example, this STL file, they will form a replica. Then that replica will be transferred to a computer screen through the CAD software. So what will happen to that software or that screen? where the replica or the picture of an object is there is a slicing or generation of a G code. G code will become activated. There are some other codes with the name of a slice 3R or Cura. So these are the other two codes which are going to be generated on the computer screen. Then the stimulation of this G code file will be there, and the three-dimensional printer, they will become stimulated through the CAD/CAM software, and then they will build a prototype, and the three-dimensional printed model will become come into the revolution. Now I'm going to discuss about the various techniques of three-dimensional printing. So there are total four number of techniques are there. The first and the most technique is an extrusion printing model technique. So in this technique there is a FTM model, that is a fused deposition modeling technique. So this is how the machine or the technique will look like, something like that. So here there is a plastic filament or a metal vial which is unwound from a coil and supplies the material to an extrusion nozzle, which can turn on and off. The nozzle will become heated. So this is the nozzle basically. This is the nozzle. So here is a heater element is there. So it will become heated this nozzle. So from here, the material or the in the form of a powder or in the form of a small beads, they come out on this platform, and there is a deposition of the material layer by layer, and they will form the replica of an object. So there is a building of the platform here by here, and the material basically used is the ABS, PLA, or the nylon, or the polysulfones, or the polycarbonate. So, however, this technique basically used to form the complex type of an anatomical models. The complex type of an anatomical models like the maxilla or the mandible, or in case of a printing of an edentulous mandible or the maxilla, we can form with this technique. There is a second technique that is called the material centering technique, where the SLA technique is there, that is a stereolithography technique or the selective laser sintering technique. So these are the models just look like this technique. So in the SLA model, what will happen? We are going to use a liquid photopolymer resin, which is again going to be deposited layer by layer. So however, in the SLA technique, the powder polymer is used instead of a liquid polymer. So this is the basic difference. In one technique, the liquid polymer is used. In the another technique, the powder polymer is used. So in the SLS, so here this is a laser beam which will activate the scanner system here, and the powder bed is going to be formed layer by layer. And this is a powder delivery system. Through the with the help of this roller, the powder will go here, and the heated material, the heat from the laser machine, they will become activated, and the melting of that powder or melting of that liquid will become here, and the fabrication of the three-dimensional replica or the object will be manufactured through the powder bed. So in the SLS technique, again the same thing is there, but here the nozzle will give you a this liquid polymer on this powder bed, and the fabrication of the three-dimensional printing model will be obtained. So still both the techniques. So this SLA technique is basically going to use the formation or the manufacturing of the surgical guide or the stent, as well as the duplication of the prosthesis. It is basically used mostly in case of when we are going to proceed with any kind of a dental implant procedure. But however, this technique is also has a certain disadvantages because of this in the SLA technique. We are going to use a liquid polymer, but always there is a shortage of the biocompatible resins, as well as this is a lengthy processing. The lengthy processing time is there, and the material which is going to use, that is a cytotoxic. Right, but in the SLS technique, again, it is used for the fabrication of the anatomical models, the slicing and the drilling guides in case of a dental models. So we can use this kind of a SLS technique for the manufacturing or the replica of the three-dimensional object. So then this is another technique, the material binder technique. So here there are two types of a technique. The thermal inkjet printing technique is there, and the powder binder printer is there. So in the thermal inkjet printing, what is going to be used here? There is selectively deposition of the liquid binding protein. So this is a selective binding of the liquid photopolymer is there, which are going through the scanner. This is an inkjet nozzle. So this inkjet nozzle will become heated through the scanner, and they will give a drop by drop a material of a liquid, and the layer by layer material will going to start depositing, and the material will bind. And there is a fabrication of the again the three-dimensional printed object. So the most important thing regarding this inkjet nozzle is the diameter. So the diameter is around 10 to 150 picoliter. It is always in a picoliter, the diameter of this inkjet nozzle. But here, the inkjet nozzle, this is an inkjet printed head is there. So this is the basic difference between these two techniques. In the powder binder printer, this is a head. Head is going to be heated, but here the nozzle is going to be heated through the scanner process. So the material going to use is a gypsum or the water in the form of a starch. So this is the basic difference between these two things. So, but this thermal inkjet printing model most commonly used in case of a tissue engineering process, in case of a formation of a cell scaffolds, in case of a regenerative medicines. And the advantage of this technique is it is one of the fastest technology with a high excellent end results. And the resolution of this technique is very high because the liquid is supplied through the inkjet nozzle. That is very advanced type of a technology. Okay. Now, this is how the machine look like on the interior aspect. This is the powder layering. So this roller will become activated and the roller will give the material layer by layer. This is a work area here. So laser beam will become activated and the laser scan the material and there is a heating of the material and they will start depositing it to the layer by layer. So this is how the powder layering is to be done in a three-dimensional printed model. Now, this is the how the processing of this three-dimensional technique will be done. Again, through the CAD-CAM technique, the three-dimensional scanner on a plain digital camera that will going to be printed, and the image will start sectioning that are reconstructed with isotropic voxels of 1.25 millimeter or less than that. Then the STL file will become created a design in the form of a triangle. Triangles are in the they will become together in the form of a puzzle, and that will going to be transferred into the three-dimensional printer. So layer by layer, the object will be start forming and the post-processing, the finishing step will be done through the cleaning, through the polishing, through the curing or through the sterilization process. This is what the processing of the three-dimensional manufacturing machine is there. Now, there are various materials which are going to be used. In every technique, different types of material is used. The material is either made up of a plastic, either made up of a metal, or either it is made up of a glass. So in the plastic, there may be an ABS material that is a acrylonitrile butadiene styrene, flexible plastic. Then PLA technique is there, that is a polylactic acid or the polylactide is there, or the nylon is there. The metals in the form of a brass, bronze, platinum, aluminum, steel, silver, gold. So all these metals, they are going to manufacture the three-dimensional object. Now, this is the basically material. For example, if we want to place a maxillofacial implants or we want to place a zygomatic implants in an oral cavity in the maxilla, so titanium is most commonly used, as we all know that it is a one of the bio-inert material, bio-compatible material with the oral tissues. Still, the calcium phosphate is also used. But in case of we want to manufacture any kind of a denture or a crowns, the cobalt, chrome, material is used and the zirconia is used. Because as we know, it is a corrosion resistance. But for the tissue engineering, we are going to use with a cell. That is, but the for the tissue engineering process, the technique that is going to be used is a micro extrusion. That is a different technique as compared to the other techniques that we are already discussed previously. It eliminates the need of an immunosuppressant because we are going to use a live cell for the scaffold in a tissue engineering process. Okay? So these are the various materials. So this three-dimensional technique has a various advantages. So one of the most important advantages is that there is a material saving. So material is there is a no wastage of a material in this technique because it is an additive manufacturing form of a three-dimensional printing. So others are the material also have a low porosity. It is free from enclosed structures and the lattices are also achievable. And it is one of the economical type of approach. And the design, they are usually formed in the form of a three-dimensional replica that can be easily shared with the other person or with the other dental lab persons. So there is also a direct production of the three-dimensional CAD-CAM models, which is a rapid production of the prototypes. But still, in addition to the various advantages of this three-dimensional technique, there are certain limitations. Every technique have a certain advantages, certain limitations, pros and cons are there. So most important limitation is there. It will the equipment which are going to be used as a three-dimensional printer or which are going to be used as a three-dimensional this software. That is one of the costly equipment, and the speed of this three-dimensional printer is slow. So this is one of the most important limitation in terms of this three-dimensional printed model. Okay. So now I'm going to discuss the various clinical applications. So where we can use in a dental office this three-dimensional technique. So it is going to be used in each and every branch of our dentistry, either in the orthodontist, as a prosthodontist, as a periodontist, as an endodontist, or in a oral and maxillofacial surgery. So in each and every branch, we can process the three-dimensional printing in terms of a treatment plan, in terms of a diagnosis plan. Now, for example, if we want to add this technique in case of a for manufacturing of a denture or crown and the bridge. So right now, normally in the dental clinic, we are going to form the denture with the help of this formative manufacturing. That is a conventional denture process where we are going to apply with the this HNet impression is going to be used to take the impression of the upper and the lower jaw. Then the flasking is to be done, then curing is to be done, and then the denture will be made. That is a traditional technique. But then the subtractive manufacturing technique was come into picture. So in the subtractive technology, this manufacturing process, the milling machine was used and the denture was formed. But this is a digital type of a denture processing. So here the intraoral scanner was used for the subtractive manufacturing. Again, this subtractive manufacturing technology is a time-consuming process, as well as the wastage of the material is very much high in case of this technique. But now the additive manufacturing, the three-dimensional printer, they will come. Here the wastage of the material is not there. The denture, the three-dimensional printed processes, we can approach with the help of this additive manufacturing for the formation or the manufacturing of the denture processing process. Now, these are the certain examples where the three-dimensional printed models are there. Or the we can make a temporary crown, or we can make a resin pattern for the casting and the alloys. So we can go ahead with the three-dimensional printed model in case of prosthodontic department in the dental lab. So I will also want to, I will share this picture. This was the first patient in the year of 99 who was treated with this three-dimensional printing technology. So for the orthodontic surgery, this patient was going to be treated through the CBCT scan, and this was the three-dimensional printed model. It was reconstructed through the CBCT scan. So this was the frontal view of this three-dimensional printed model. So it was actually it was formed by this FDM technology, which shows the complex anatomy of the maxilla as well as the mandibular area. Even this was an aligner, which is most commonly used nowadays in an orthodontic department. So this is an aligner which was built through the CAD/CAM technology. So this three-dimensional printed model we can use as a surgical guide in case of we want to place a zygomatic implant. So this is the surgical guide which are going to be used, which are going to be manufactured with the help of this three-dimensional printing process. These are the zygomatic implants which are going to place in the maxilla or the mandible. But this surgical guide, or they are using as a stent or as a formation for the implant insertion to know the exact place where the zygomatic implants are going to be placed. So it is also used in case of this patient-specific implant manufacturing process. So this is the replica of the three-dimensional printed model on a computer screen, basically. So this implant is going to be placed into the edentulous mandible, into the subperiosteum. So this is the OPG which is going to show that is the three-dimensional printed model which are going to be placed into the edentulous area of the mandible. So even it is also used in case of an alveolar ridge preservation. It is used in case of a reconstruction plate using a SLA model technique. So even for the TMJ reconstruction surgery due to the oncology resection, it is going to be used. However, basically, this was the patient who was having this gunshot injury on the this left side of 8 years ago. Old bony plate which was placed 8 years ago because of this was an OPG, or this was an this X-ray which shows basically infection which was developed at the surgical site, and the fistula was formed here. So this was the surgical guide or the stent which are going to be manufactured through the three-dimensional printed model. So this was inserted here into the below this SLE model. With the help of the SLE model, this surgical guide was constructed and the plate was fabricated. So this was the after post of a picture. This is already this was the plate basically. They has proceed with this gunshot injury where the fistula has been already formed. So this was the post of a picture. So, PSI for the reconstruction of the large mandibular defect in case of a tumor resection. Again, this is a subperiosteal this implant in the edentulous mandible. That is the after placement of a dental implant. So, basically, in case of a dental implant, in case of a tumor resection, this 3D, 3 dimensional printed models, they will help you in formation of the surgical guide or formation of the prosthesis or manufacturing of the prosthesis as well as the surgical stents we can manufacture with the help of this 3 dimensional printing. Also, it will give you an accurate positioning as well as the accurate anatomy of the complex anatomical structure. So this is the important step where when you are going to place an implant, where you are going to place any kind of a bony reconstruction plate. So it is also used in case of a fibrous dysplasia, in case of a periosseous defect. So this was the defect, this was a defect model basically, and this was a surgical guide or that is going to show you in a blue color basically. So scaffold matrix is going to be formed with the help of the tissue engineering process. This is the 6 months and the 1 year post-operative clinical picture where the probing pocket depth is very less. That is around 2 to 3 millimeter. But however, this case, after 2 years, the scaffold was exposed because of the gingival recession here. So this scaffold matrix was basically formed through the tissue regenerative process and formed by the micro extrusion process with the help of this 3 dimensional printed model. So in the dental clinic as well as in the dental lab, we can use this 3 dimensional printed model in both the techniques. So first of all, again, we in the dental clinic, when the patient will come into the dental clinic, the 3 dimensional intraoral scanner was used. Then we will go ahead with the CAD/CAM software and the 3 dimensional printer will form the replica of an object and the patient treatment is going to be started in a dental clinic. But in a dental lab, again, the manual impression, either with any kind of an impression technique, with any kind of an impression material we can use. But here we can use the CAD/CAM software and the 3 dimensional printer for the further formation of any kind of dental processing or manufacturing of the replica of an object. So this is one of my article which is already published in the year of 2021 in IP International Journal of Maxillofacial Imaging with the name of a future dental devices, the 3 dimensional printing approach in dentistry. So if we talk about the literature of these 3 dimensional printers, these are the scientific evidence. Firstly, the studies was done in vitro as well as in vivo on an animal. So Kim et al. In 2000 did the study on rats, and he concluded that a putative pedontal ligament cells as well as a new bony regenerative at the interference of the rat incisor scaffold with the help of the native alveolar bone by the cell probing. So it means when they are already placed this 3 dimensional printed surgical guide or the stent into the defect, the pedontal attachment apparatus was going to be formed. It was a positive result with the new formation of the bony cells as well as the bony regenerative material as well as the formation of the alveolar bone. So in the year of 2014, Lee et al. Did the study again on the mice, and again they concluded that the scaffold which are going to be yielded as a DPSC scaffold cells, they aligned the pedontal ligament cells like a collagen fibers. So collagen fibers, they are into the orientation, but along with the orientation of the collagen fibers, the pedontal ligament cells, they are also come into the orientation with using this kind of a technique. Again, the results was positive in an animal studies. However, in 2015, the study was done on clinically. The study was done in case of the patient is already having a chronic periodontitis, and the patient examination was done. There was a moderate to deepest pocket was there, as well as was a loss of clinical attachment loss was there. But the patient, the case was demonstrated after the this demonstrated a 3 millimeter of a gain in a clinical attachment loss. So clinical attachment loss was regained after the case was treated with this SLSA technique, and the material they used is the PCL material, special material for the 3 dimensional printed. So this was the case. So the first clinical case was treated in 2015. However, in 2011, Moria et al. He did the orthodontic mini screws into the clinical practice. So these are the certain future applications of this 3 dimensional printed technique. So again, in case of an osseous defect, the image is going to be transferred on a computer screen. Then there will be a designing or the manufacturing of the image-based scaffold. that cells will go for the periodontal tissue engineering process, but it will take a 2 days, because the periodontal tissue engineering process, it is through the microextrusion process. They are going to use the live cells for the formation of a scaffold matrix. Then the evaluation will be done on the computer software, and then that computer software will give you a green signal, and then we will go ahead with the transplantation of the this scaffold matrix onto the periodontal defect we are going to be used. So this is how this future application of this three-dimensional printed model or manufacturing process is going to help the practitioners into the dental practice. So regarding the future of our technology in India, so there are various key initiatives in India for three-dimensional printing process. There are certain organizations which are giving a partnership with the global institutes, the Ministry of the Electronics and the Information Technology. They released a national strategy for additive manufacturing in the year of 2022. This was a recent data which was given by the Ministry of the Electronics and the Information Technology. Even in Aurangabad, the National Institute of this Electronics and Information Technology established the three-dimensional printed lab. Okay. So these are certain recent developments. Again, in the Bangalore, the first India's first three-dimensional printed post office was created in Bangalore. But in the Telangana Siddipet district, there was a world first three-dimensional printed temple in Burugupalli was unveiled. So these are the pictures. So this was basically the two buildings. This was a post office, a three-dimensional printed. This whole building was a three-dimensional manufacturing process for the three-dimensional printing model. So this was a world first three-dimensional printed temple in Siddipet, Telangana district. So, if we will talk about the all over the world, in Los Angeles, California, United States, these all countries offer a professional three-dimensional printed solution for the digital dentistry, as it provide a fully integrated dental appliances designs for its sprint array, and the three-dimensional printer add a range of products such as like a desktop three-dimensional printed or the printing material and the post-processing system. So this was the percentage data of the dental three-dimensional printed marketed share by the region. So Asia Pacific along with the North America, they are one of the highest market sharing in terms of a dental three-dimensional printed market. By the this was a recent data by the ending year of 2023. So these are some dental companies. The most important dental company is Trace Limited in 2013. He was the first commercial consumer printer company which make the three-dimensional printed company with printer with the name of a MakerBoot. MakerBoot was the first three-dimensional printer which was which was manufactured by this Trace Limited. Other companies are also there, like Stroman companies there. Then there is a Dentsply is there, Envision is there, SLM Solution is there, Broadways are there, Roland is there, three-dimensional systems are there. So all these companies, they are going into the world market for the processing of this three-dimensional printing machine. So most recently, in September 2024, there was a 3 post-processing tools and 2 new resin materials that were among many new products formed by the Forms Lab, which is launched through the SLA technique, through the SLS technique. So this company offers a more newer 45 materials in the range of 2 newer material. One is a clear cast resin. Second one is a Versio Smile Trinity resins. So these are the 2 newer materials which are formulated by the Forms Lab. Again, in May 2024, in addition to this announcing a partnership, they also have a partnership with the Ivoclar company with a name of a material that is a Pro 2, one of the newest desktop three-dimensional printer in the company lineup. Sprinteray is also one of the leading company in terms of a three-dimensional printed model with the joining the hands with the Ivoclar company, and this is Sprinteray three-dimensional printing ecosystem, thereby increasing the access to a wide range of restorative materials. Okay, so now I'm going to conclude my presentation here with three-dimensional printing technique gaining its popularity in the various branches of the dentistry, as it have a capacity to revolutionize the dentistry and give a new direction to the dentistry field. The ultimate goal in dental practice is to provide the most technologically advanced dental treatment to the patient with high accuracy and least discomfort. It also permits a greater predictability in dealing with the complicated interdisciplinary scientific scenarios. It also provides a better educational tool to most of the dental procedure, not for the practitioners, but also for the academicians as well as for the dental students. These are my references, and thank you for the patience.